Okay, so today we're going to look at graphing these absolute value inequalities. So yesterday we had solved them, and now we'll see if we can graph them as well. So let's just take a look at the first one. Unfortunately, they put the number line right underneath the problem. I wish they put the number line like at the bottom, but that's okay. So I'm gonna ignore the number line for a minute. And we're going to start solving this just like we did on our homework. So first things first, I got to get the absolute value by itself. That is what? Eventually, yes. So I want the absolute value alone, and that's already the case. So now I'm ready to rewrite it twice. So I write it as -9 plus x greater than or equal to 3. The first time, literally just like I see it, no absolute value bars. The second time, it's still -9 plus x. That does not change. But now I'm flipping that symbol over and I'm taking the opposite of that side. Okay, so there's our two. We're going to solve each one separately, just like we did last night. And just like last night, we are deciding if this is an and or an or. So what would you guys say? Is this an and or an or?
Or, right?
You are right, because I don't have any numbers that are greater than 12 that are also less than 6. Right? That's impossible. So that's how I know, all right, it's going to be an or. So now I want to go back and I want to graph that. So hopefully you remember from our compound inequality unit how to graph this. So ors are relatively easy because I just graph each one separately. So I want x is greater than or equal to 12. So what kind of a dot do I put at 12? Close dot, and I'm going to shade, I want all the numbers that are greater than 12. So do I shade to the right or to the left? To the right. Remember, when the variable comes first, this tells you which way to shade. It's saying, hey, go to the right. There it is. Now I'm going to graph this one. X is less than or equal to 6. So what kind of a dot is 6? Close, and I shade to the left in this case. That would be my entire solution. So there's the solution and the graph of the solution. By the way, remember that the graph is really kind of nice because anything that you have drawn an arrow over, you're saying is a solution. So if you wanted to, you could take a number like 5, right? 5 is a number that I've drawn an arrow over. If I plug 5 back into the original, it should work. Right? -9 plus 5 is -4. The absolute value of -4 is +4. Isn't 4 greater than or equal to 3? Yes, that's true. It does work, which is why it makes sense that this is part of my solution. If you plugged in a number like 9, let's say, or 10, even easier, you plug in 10, it's not going to work. Try it. If I plug in 10, -9 plus 10 is 1. Absolute value of 1 is 1. 1 is not greater than or equal to 3. So it makes sense that 10 is not part of my solution because 10 doesn't work. Okay, you try the second one without me guiding you through it. I'll leave number 1 up here as a model, but do the same thing. You're going to solve it, decide if it's an and or, and then go back and graph it. Did this one end up being an and or an or? What'd you say? And? I don't know what the answer is. All right, let's try it. So step one, absolute value by itself. Oh, good, that's already done for me. So I don't have to worry about that. Step two is to rewrite it twice. Negative 9p greater than 9 and negative 9p less than negative 9. You have to do both, right? Flip the sign and make that negative. Yeah.
When doing the problem, you flip both of the signs because you have to, it's negative.
You got it. So when I go to solve this one now, I'm going to divide both sides by negative 9, right? Anytime I divide by a negative, I got to flip that symbol over. So it gets flipped again. I just divided both sides by a negative. So that symbol has to flip over. So flipperoo. Same thing's going to happen on this side. It's going to flip again. So now that I have flipped them both, let's see, I need a number that is less than negative 1 and greater than positive 1. Is that possible? No. So this one's got to be an or. So this would be your solution. And then we're going to go ahead and graph that solution. So what kind of a dot do I put at negative 1? Open. And we're shading to the left. P is less than. Greater than 1, so we'll put an open dot at positive 1, and we're going to shade to the right. Remember that ors almost always just graph away from each other. Almost always. Ands are going to be the ones that go towards each other that just make a bar. So let me see if I can find one real quick that would be an and. I think 5 might be. Give me 1 second. Yes, okay, let's do 5 together just so we have one of each. All right, so step 1, absolute value alone, already done. Okay, great. Step 2, let's rewrite it twice. Negative 10 plus p is less than 12. And then I write it again. Negative 10 plus p. I now flip the symbol over, make that one negative. Okay, so everybody go ahead and solve these two. Let me see if we all end up in the same spot. Okay, did you notice that this one ends up being an and, or did you get an or? It was supposed to be an and, so let's try it. So on this side, I'm gonna have to add 10 to both sides. Okay, so I get p is less than, that'd be a 22. And I'm gonna come over here, I'm also gonna add 10, but when I add 10 to negative 12, that just gets me negative 2, right? So I need a number that is less than 22 and greater than negative 2. Does such a number exist that's less than 22 and greater than negative 2? Yeah, sure. 7, right? There's plenty of them that you can pick from. The fact is that there's some that exist. I just need one. There's a whole bunch, but as long as there is a number that exists for both, then it's going to be an and. Okay, so if you don't want to rewrite it as an and sandwich, you don't have to, but I personally think it's easier. I take the smallest number, P goes in the middle, the arrows always go the same way. And the reason why I think that this is easier is because this kind of tells me the endpoints of my graph. I know I'm gonna be at -2 and at 22, and then I just shade in between them. That's it. So if I know it's an and sandwich, that's all I'm doing. Just making sure that I have open dots at -2 and 22. So I'll have an open dot there and then an open dot all the way here at 22. And then I just draw the line in between them. That's it. You could get there without rewriting it as an and sandwich. I just think it's easier. I just put the dot at my lowest and my highest shade in between. Ands almost always do that. They almost always just make this bar, so it can be nice and easy. All right, let's try one of the trickier ones together. So if you look at the back, they get a little bit, a few more steps. So I bet you'll probably want to do one of the ones with a fraction in it, huh? Does anybody have a preference between 9 or 12? I actually think 9 is worse. Let's do 9 together. Okay. Step 1 is to do what? Yeah, I gotta get that absolute value alone. So I'm gonna divide both sides by 10. Why? Because I'm multiplying by 10. So let's divide by 10. And that's gonna get me this. I'll put it right here. I'll get the 10s will cancel out. I'll have absolute value of n over 8 is less than or equal to 5 over 10 is gonna reduce down to be a half. So there's still a fraction in this problem, but that's okay. It's not so bad. A half isn't so bad to work with. So now I'm ready for step 2. Let's rewrite this absolute value twice. Once just like I see it. Once I'll flip the symbol and take the opposite. Okay, so once just like I see it. N over 8 less than or equal to 1/2. And the second time, n over 8, flip that symbol over, make that negative. And now I just have to solve each one. Again, not as bad as you think it is. If I'm looking at that first one, what do you do to get that n by itself? How will you get rid of that 8? Exactly. I'm dividing by 8, so let's just multiply by 8. So if I multiply both sides by 8, those 8s cancel. So on the left, it's really just n, and then what's 1/2 times 8? 4, right? Let's get a 4 on the side. That wasn't so bad. And now let's do the same thing on the other side. So over here, same thing. I got to multiply both sides by 8. Those cancel. And now it's just negative 1/2 times 8. So what's that? Yeah, just a -4. And now we determine, is this and or? Do you have numbers that are less than 4 that are greater than -4? So sometimes I pick a number, right? Just start with the first one. Pick a number less than 4. So just try 3, right? So then if I bring 3 over here, is 3 greater than -4? It is. So I do have a number that works for both. And. Right? I like to rewrite it as an and sandwich. You don't have to, but it makes making the graph so easy. Take the smaller number, whichever one it is. In this case, it's -4. The n goes in the middle. The bigger number over here. That's it. The arrows always point that same way. So now I know exactly where to put my dots. I see that my dots should both be what? Open or closed? Closed. So we said closed, right? Okay, so a -4, I didn't give myself a ton of room, but there we go. A big old closed dot on -4 and another one on +4. And then I'm just shading in between them. I just draw that bar in between. And that's it. You can always check this. A number that you shaded over, you're saying will work. So take 0. 0 is super easy to work with. If I put 0 in here, I get 0. Absolute value of 0 is 0. 0 times 10 is 0. Is 0 less than or equal to 5? Yep. So I know that I shaded the right way. How are we feeling? Okay-ish? So what I think I'm gonna have you do is, I think I'm going to probably do 2 rounds again. I'll have everybody do one of the problems on the front that we haven't done yet. And then I'll have everybody do one of the problems on the back that we didn't do yet. I think that's my plan. Okay, so you are welcome to, yeah, okay, so keep doing the problems. Hold on, let me see what's on the back. Yeah, okay, we'll try that. Anybody have a question right now? You okay? All right. And you can even leave this sheet at your desk if you want, because I have extras. Okay, give me a second to just end the video. Probably. So if you want to start working your way through them, so you have less later.